Today I'm going to have a look at earth batteries and just do a comparison, see if different metals produce different amounts of voltage. So got a copper tube there, so I'll connect to the positive of my multimeter, and then I've got some different metals here on this side. You can see neodymium magnet there. All these are ferrous metals, every single one of them. So magnet sticks to all of them. Magnet sticks too well to that one. And literally they're just pushed into the soil. Screw pushed into the soil. Bolt pushed into the soil. Another bolt just pushed into the soil. You get the picture. There's not really a lot of soil in this plant pot, so quite hard to get them to make a contact, but we shall have a look, see what voltage we can get off any of these, if any. Hold the positive probe onto there. Look at that, 0.8 of a volt. Put it onto the screw, 0.75, put it back onto there, 0.79, we'll get off this one, 0.63. Mild steel, 0.4, back onto the screw, connected to the screw, 0.76, 0.77 of a volt, back onto there, 0.8 of a volt, back onto that, what we've got there, 0.63. Now it's worth noting that all this is two different metals in some soil. The soil is obviously damp, but it's just normal tap water, and we can get a voltage, which to be honest is pretty amazing. I'm going to do some more experiments and see if adding maybe salt to the soil has any effect, something acidic, something alkaline. I'll try those and I'll let you know. Just to get a baseline reading, bog standard tap water. I'm just going to put a tiny little bit in. Tiny bit. Mix it around a bit and we'll see if this makes any difference to the voltage that we're getting. Obviously there's going to be salts and minerals and things in the soil. That's obvious. I mean, this compost it's just something I've been and dug out of the garden. I have grown plants in it, I've grown potatoes in it this year. What else? I think carrots last year. So it's I have added nutrients to water and put that into the soil. Okay, so just for a baseline reading now, just bear that in mind. Okay, I've got the same three things. I've got a screw which I've got, I think it might have been galvanized, well, it's brass coated at least, I know that much. A piece of brass and a galvanized bolt. So let's see if we can't get the positive probe into such a position where I don't have to hold it. We'll see. Let's see what happens now. Yeah, there we go. Okay. I know it's fluctuating a bit, but that is just because the connection's not very good. The connection from the multimeter is not very good. So I'll try getting a better connection. And then I'm going to use some chemicals to see if we can't boost the voltage. Just ordinary household chemicals. Right, there we go, that's decent. So 0.8 of a volt, 0.79, 0.8. Okay. That's from galvanised bolt. From the brass, 0.3.4 on the screw, about 3/4, 0.8. Okay, so that's my baseline. I shall now go and measure out a certain amount of water. I think I'll probably stick with 30 mils, and I will put a specific amount of chemical in there, so I know, you know, it's scientifically measurable what I've done. 30 mils of water in there, and I'm going to mix using a syringe 1 ml of ordinary malt vinegar that I've just been to the shop and bought, and we'll mix that in there and we'll see if we get a difference in voltage. So, ordinary as the Smart Price malt vinegar. If I can get the lid off it while holding the camera, which I don't think I can. Okay. There we go. So I'm just going to draw up into the syringe. Syringe is a 1 ml syringe. So, I mean, concentration of acid to water is 30 to 1. So we've got a syringe with 1 milliliter of acid in. Put it into the water. Give it a stir. Now, obviously, to make sure that my acid and my alkali don't react with each other, or cause any discrepancies in my results, I am going to go outside and I'm going to dig from exactly the same place, and I'll make sure my baseline readings are the same as well. Some more soil after I've performed this test, so not even going to put it all in. I've put 15 mils in. Okay, and we'll see. Give it a mix round and we will see if that makes any difference whatsoever. Rocking there as well, look, as you can tell it's been out in the garden. Okay. Double check that we've got a half decent connection on the positive terminal. Okay, and there we go. We've gone from 0.79. Oops, positive terminal's come loose again. I need somebody else to film this while I do it. To 0.84 by adding half a ml of acid to 15 mils of water. Let's see what we get on the brass. Don't forget we're at 0.3, 0.4 before. Yet again, let's come off. Okay, I'll find a way I can film and hold both probes. Not very easy. Okay, the brass 0.35. Now onto the screw again. 79.8. I shall now go outside, I'll empty that soil and I shall get some fresh soil, and then we'll try mixing an alkali into the soil and we'll see what results we get with an alkali. And we will do the copper tube as well, look, so that nobody thinks there's any cheating. Now I have actually pushed the soil out of there, look, you can see. The copper tube is clean. Put that into the soil. Like so. And screw. Bolt. Put that into there as well. Now, I did clean out the plant pot as well, otherwise there would have been no point washing everything else with it would have just been a fruitless exercise. would have served no point whatsoever. So, okay, right, we'll now do the baseline test. So, that's DC voltage. So, let's see if we can get the same baseline test, same baseline results. And I've got 0.7 on that. Alright, this was my best one. Yeah, we had 0.75 before, we've now got 0.73. And this was the worst one, it's about 0.3. Yeah, there we go, 0.27. See if moving the electrodes around or makes any difference. Different points. It's about the same, 0.3. I mean within 1% of the same values as we had before. 2% on that one. Now that one's the biggest change, because this was 0.7, I think it's 0.72, 0.73, so it was 4% difference. Right, so next I will hydrogen peroxide, that's our next one. Ordinary bleach. Bogo standard household bleach. We'll suck 1 milliliter up into there. I don't know if you can see that. We'll bang on 1 mil now. And I shall put that into the water. Give it a good stir around. But if I was being really scientific, I should stir so many times that way, but as long as it's mixed well enough, I don't suppose it's going to matter, is it? The rest of the bleach back in there. Okay, and as before, I'm only going to put about half of this in. Just a bit more. A bit more. 15 mil line. There we go. Okay, I'm just going to take my electrodes back out and give it a stir. See what we get. Okay, back in there. Make sure it's not surface area. Roughly the same as what I had before in contact with the soil. Okay. Different order, I know, but it doesn't really matter for that, I don't think. Make sure that they're packed in well. Okay. Over a tiny bit. Try again. See what we get. 6 and 9 still on there. Roughly 0.3. What do we get here? So that's made no difference whatsoever. That's strange how the acid did and the alkali hasn't. With an acid, that proves that an earth battery works with galvanic reaction. I mean, if you get a pH meter and test soil, it's nearly always acidic. So, you know, what I'm going to try now, obviously, because like I just said, soil is always acidic, put some more alkaline in there. Granted, it's going to be really wet soil, however, look at that. Copper oxide. Okay. And we should try this again now. Just basically to try and counteract the acidity of the soil. No, we're about the same. More or less exactly the same. Actually, the brass has dropped. It was 0.29, it's now 0.25. So we know that adding alkali really has a detrimental effect to an earth battery, whereas the acid has, has a good effect on it. It increased our voltage by at least some. Now, after doing a bit of research on the internet, found out that this is also possible using salt water. So, using salt water as an electrolyte, I am going to go up to the beach, and we'll try the same thing on the beach, because I'm lucky enough to live near a beach. Not a very nice beach, but still, it's a beach. There we go. So we will take this experiment on a little road trip. Okay, so we're walking up to the beach to perform our experiment. The shit thing is, the beach is like 500 feet that way, and I've got to walk half a mile down there to get to it. Okay, so here we are, arrived at the beach. Tide's in. Let's cross over the railway line and goes to Cleethorpes. So we'll get down to the beach, get things set up, see what happens. Walked up to this end of the beach where there's hardly any sand because people walk their dogs on this beach. So keep out of the way of all the bloody dogs. And we'll set up somewhere here. I'm going to make an assumption that it's in as though all this is wet, the tide's on its way out. Which I should have checked before I set off, but never mind. Let's have a look and see what happens now. Okay, another one, stainless steel. Okay, so on the screw again, we've got best results with the screw. I'm going to try now wiring up some of these electrodes in series and see if we can't boost the voltage. If you can see those ships in the background, I can zoom in, there we go. After an extremely steady hand and some crappy digital zoom. There we go, that's what Cleethorpes Beach looks like today. Go back to the plant pots and just see if we can wire a plant pot cell up in series. See what happens. Okay, I've come back home and just doing a bit of experimenting really. So I've got 6 plant pots, each of which has got a pair of electrodes in. So if you look, basically there's a screw there and a piece of copper pipe there, and obviously I've gone from the copper pipe is the positive terminal and the screw is the negative terminal. So I've wired them up in series. You can see copper pipe, screw, and then the screw's connected to the copper pipe in the next plant pot. Then we've got screw connected to the copper pipe, screw connected to the copper pipe, screw connected to the copper pipe, blah blah blah, all the way along. Okay, now I've put a piece of copper wire off that screw just in my multimeter there, so I don't have to mess about holding both probes. But if you take a look at the multimeter, when I connect it to there, and look, I've connected it to the copper pipe, and we're at 3.8. Proper connection. 3.86 volts. So 6 plant pots, nearly 4 volts. Now that is enough to light an LED, which I'll demonstrate in a minute, but it's not enough to spin a 5-volt motor, so obviously the current isn't very high. I mean, I can get the 5-volt motor to spin at, I think, 4 volts with 185 milliamps. It spins very slowly, but it still spins. So, otherwise you can see properly. Yeah, I'll demonstrate it like this 6 plant pots lighting an LED in just a second for you. So I know this little arrangement of LEDs looks a bit strange, but it's actually for an ArDweNOme project that I was prototyping. So now you can see I've connected the negative to that wire there coming off the screw, and the positive is there. Now if I connect that to the copper, let's see if we can get this in the dark just enough for you to... There's lit an LED with 6 plant pots, 6 small pieces of copper, tubing, 6 nails, and a little bit of copper wire. And there we go. We have got an LED lit. I'll try connecting some more up and see how many LEDs we can power. So I've connected up another LED, another one of the red ones. You can see that that resistor there goes to a yellow one, and that resistor there goes to the other yellow one. Obviously there's 2 red, 2 yellow. So we will see now if we can light 2 LEDs with the plant pot battery. Let's have a look. It's quite difficult to see, but those 2 LEDs are lit. In just the right spot, you can see they are lit. I'll disconnect it to prove it. Connect it back up. And there we go. There's definitely enough current coming from these 6 plant pots to power 2 LEDs. Admittedly not very brightly, it powers one a lot better, but there we go. Back garden fuel cell. I wish I could tell you how many milliamps we were producing, but my brand new multimeter, and it is brand new as well, I've only had it about 3 or 4 days, the ammeter part of it doesn't work, so I shall have to send that back to Amazon, I do believe. Well, there we go, there we have it. I can get as much, almost as many volts from 6 plant pots as I can from that solar panel. And the difference is they don't require any sun. Robert Murray Smith's video for the 4th of July is all about experimental methodology, and he suggests that you keep it simple. So, I mean, if that's not simple, I don't know what is. 6 plant pots lighting a red LED. This is something that anybody can do. All you need is some scrap pieces of copper piping, some screws, some copper wire, some plant pots, some soil, an LED,